Welcome back to the course on analytics here. So, I will continue my correlation lecture here. So, previously we discussed the Pearsons product movement correlation. In this lecture, I will try to discuss Spearman's rank correlation coefficient. First, I will differentiate this from the Pearsons coefficient. Then we will test the hypothesis for RS. Then we will see does correlation institute causality, and we will see how are these related. So, first we had Pearsons product movement correlation that was based on interval data. Now, question comes, what if the data is ordinal? Can we have the correlation? In that case, we can compare the orders, or I can say we can take the help of Spearman's rank coefficient to convert. It is used to convert the interval to ordinal scale. So, when we are talking about ordinal scale, we are talking about the ranks. Ranks are obviously in ordinal scale. We have the ranks, rank 1, rank 2, rank 3. There is an order associated with this. So, Pearsons product movement correlation, this measured only the degree of linear association. Does there exist correlation between X or Y? It is based on the assumption of bivariate normality of two variables. Spearman's rank correlation takes into account the ranks. And it measured the degree, here also it measure, here it measure the degree of monotone association. To clarify this, I will take an example, I will solve it before you. So, inferences on the rank correlation are distribution free, because we are just talking about the ranks. Once we have given the ranks to our data, we have ranked the data, we have put our data in an ordinal scale, then we do not think about a distribution at all. So, how do we calculate? The Spearman's rank correlation coefficient is denoted by RS. This is equal to summation I is equal to 1 to n ui minus u bar vi minus v bar over summation I is equal to 1 to n ui minus u bar whole square summation I is equal to 1 to n vi minus v bar whole square. So, what are ui and vi here? Ui and vi are the ranks for two variables. Maybe I will call it f for xi, this is for yi, and u bar is the average rank here, v bar is the average rank for variable y, and this relation tells us the Spearman's rank correlation. So, there are certain steps in this. First we do, number 1, we assign the ranks. Assign the ranks to a data, then we find the difference in ranks, and using the relation that is mentioned above, we find the Spearman's rank correlation. And also if ui and vi are integers, Spearman rank correlation can be given by this relation. Where di is actually the difference in ranks. So, to elaborate this further, I like to take an example here. So, this is the students in the class. There are, let me say the name of student is A, B, C, D. This is just the nominal scale, and we have marks for the subject X and marks for subject Y. These are both interval scales. So, let me say this is my xi and this is my yi, and I have the rank ui and vi, which are for xi and yi respectively here. So, if I rank them based on the marks, the student having maximum marks would get rank 1. So, I think this gets rank 1, and similarly rank 2, 21 is rank 3, we have 221. So, if there is a tie, we give the mid ranks. In this case, we have 221 values 1 and 2, and ranks were 3 and 4. We will give 3.5 here and 3.5 here. And if there are 3 or 4 variables which have tie in them, then similarly we can also give the mid ranks. So, let us suppose there are 4 21s, 3, 4, 5, 6. The average would be 5.5. All the 4 these 21 values would be given rank 5.5, 5.5, 5.5 and 5.5. In this case, we have this tie, so this rank is given 3.5 and 3.5. After 21, we have next smaller number is 15. So, 3, 4 goes out and we have rank 5. Then okay, we have 15 and 15, 2 numbers, again we have a tie, then we will put 5.5 and 5.5. So, this gives rank 5 and 6, those go, and we have left with rank 7. Again we have a tie, 12 and 12, this 12 and this 12, then 7.5 and 7.5, 7 and 8 goes, then we are left with 9 and 10. This is the rank for xi. Similarly, will give the ranks for yi. So, in this case 29 is the maximum. After 29, 2 is 24, 3 is 23, 1, 2, 3. Actually there is a tie 23 and 23 here. So, I will give 3.5 and 3.5 here. So, after 23 we have 22, 3 and 4, the rank is 5. Then 21 is again tie, we give 6.5 and 6.5. After 21 it is 15, 7 and 8, then 9 and 10. So, these are ui and vi. Then we put ui minus u bar, vi minus v bar, then we put ui minus u bar whole square. Then in the next column, I will put it here, the next column would be vi minus v bar whole square, and the last column would be ui minus u bar into vi minus v bar. So, I can have total sums here, then I can use the relation to find the rank, to find the Spearman's rank correlation, to see the association here. So, then I can use the relation, that is the RS relation, in which we have ui minus u bar and so on. The relation is given in the relation is given in the previous slide here. So we can use the RS relation to find the degree of monotonous association. So these are only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have just created an hypothetical data here. So we had only 10 entries here. So we just saw and assigned the rank here. What if we have 100 entries? What if we have 1000 or more entries? We cannot do it manually very easily. So I'll try to take this data in Microsoft Excel software, and we'll try to solve this. We'll try to do all these calculations using the software, using Microsoft Excel. So I have copied my data in Microsoft Excel. We had student name here, and we have xi and yi. Now I'll calculate rank ui, that is for xi, rank, that is ui, then we will calculate rank for yi, then I will see ui minus u bar. Then vi minus v bar. Actually this is the average value, u bar and v bar. Then I will put this ui minus u bar squared. Similarly, I can put vi minus v bar squared. Then I will take the product of the differences, ui minus u bar into vi minus v bar. So first thing is assigning ranks. So how does our Excel help us to do that? So first I will put some number here, some number. So let me cut this and paste it here. I will put some number here, or I can even call it a serial number. Serial number 1, 2. So if the number is 1 and 2, in Excel this is one kind of plus, the cursor you are looking at here, this is selection tool. Also we have move tool, the second plus, this is the move tool, we can move this one. The third kind of small plus is the copy tool, and it will copy the format here. So if I drag it here, it will give this number 1 to 10 here. Similarly, I will insert a row here and copy this row and paste it here as well. Now I will assign the ranks. So let me bring this rank here. Now it would work. So first let me work on the variable x. What I will do, I select these two columns and go to sort and filter. So I can custom sort. I can sort this based on the serial number. Actually I will sort it based on the marks x for which I need to assign the rank. So largest numbers is given the rank 1. So I will sort it from largest to smallest. So it has sorted it down. So I can assign the ranks here, 1, 2, 3.5, 3.5, 5.5, 5.5, 7.5, 7.5, 9 and 10. Now I can bring them back to the previous order. This was the purpose for which I induced this serial number here. The serial number was induced to bring it back to the previous order. So I'll sort it again, sort, custom sort based upon the serial number. Okay. Now we have the same marks, it is in the same order. The student A 12 marks, student B 2 marks, and it has this rank. So it is sorted accordingly. Similarly, we can assign the ranks to my variable y. So this is actually rank Vi. So let me do it again. I'll sort it from largest to smallest, custom sort it based upon the marks y from largest to smallest. Okay. Then we have got the largest number here, number 1 rank, 2, 3.5, 3.5, 4 and 5, 6.5, 6.5, 8, 9 and 10. Then I'll bring it back to the original order, so as for each student, for the specific student A, his marks comes correspondingly. So let me sort it based upon the serial number from smallest to largest. So this was the use of the sort tool which I did here to give the ranks. So now we can hide these numbers. Even you can delete the columns if you want. So we have got the ranks UI, VI. Now I can have the average here. I put here is equal to, when we put is equal to, it gives the formula. So this becomes the formula tab now. In this formula cell, I need to take the average of this value. I will write AVE RAGE, average. I found the value here. Double click here. Now it is asking average from which to which number. So I'll select this whole column here and press enter. So it has averaged the ranks here, the UI bar. Similarly, I'll take the average for VI. So this is equal to average VI. This is actually now U bar and V bar. I can write it here. This is U bar, this is V bar. So now UI minus this UI minus U bar, means you take the difference. Now I will put the formula here is equal to this value UI, it is the cell D3, minus this U bar, enter. So 7.5 minus 5.5 is equal to 2. Now I will copy the formula. Before doing that, I will fix this cell U bar, because this is the cell which is being subtracted from the each value here. So to fix this, in this formula, I will put a dollar sign before D and 1, 3. Now column D of Excel sheet and cell number 13 of this Excel sheet is locked, column D and cell 13. So this is this one, 5.5, enter. Now if I copy the formula, it will subtract U bar from each of the UI. 10 minus 5.5, you can see 10 minus D13, 9 minus D5, 9 minus D13. So you have got UI minus U bar. Similarly, we can have VI minus V bar. I can copy the formula here and I'll just change the VI. VI is column G. Column G. Column G. So I feel now the formula holds true here. So this is 3.5 minus 5.5, that is minus 2. So in this case also this is locked, V bar is locked now. Now I can copy the formula. So I have got Ui minus U bar, Vi by minus V bar. Now I need to take the square of this value. Now I will put here this value raised to the power 2, enter. So this is 2 square 4. Similarly, we will have, if I copy the formula, again to repeat, to copy the formula, the small plus sign would copy the formula here. So this is 4.5 square, this is 2 square, this is 2 square, this is 4.5 square, this is 3.5 square and so on. Similarly, I can calculate V bar. I will just copy the formula like this. Now in this case, it was cell H for which it was taking square. When I copy the formula, I have moved it one cell forward. So it has taken one cell forward here. From it was in cell J, it was H3 square. If I move forward after H, we have I, it has turned to I3 square. So in the similar way, I will copy the formula. See, this is I3 square, this is I4 square, this is I5 square and so on. So we have got Ui minus U bar, Vi minus V bar squared. Then we need to take the product of Ui minus U bar and Vi minus V bar. So this would be equal to Ui minus U bar multiplied by, the star is multiply, multiplied by Vi minus V bar, enter. So we have got the product 2 into minus 2 is equal to minus 4. Similarly, 4.5 into minus 3.5, this value would come. Now in the formula, if you remember, we had Ui minus U bar summation in the numerator, and in denominator we have the square root of the product of Ui minus U bar squared and Vi minus V bar squared. The product of these two taking square root is in the new denominator. In the denominator we have this product. Now this squared value is always a positive value. Now the direction of the correlation would depend upon these values, because this is the product of the negative and positive values. Okay, these two values are being multiplied here. So let me take this sum, this is equal to SUM, sum formula, double click, sum of these, enter, copy the formula here. It has taken the sum of K, K3 to K12, here K3 to K12 sum is taken. So similarly, I can copy the formula here, it has taken the sum of Ui minus V bar. So since this value is positive, we will have a positive correlation. Now is the correlation strong, intermediate or weak, that we will see. This is for sure that the correlation would be positive. Now let us see the direction of the correlation. So this RS or rank correlation, I will put it in this cell. This is equal to this summation divided by the product of the square root of first, square root of the product of the differences, this cell into this cell. So enter. So this is 0.126 is my rank correlation. So that means, if you remember, 0.12 value is a weak correlation, but it is a positive correlation. That is, the subject's marks, the rank, the student who is getting marks in subject 1, good marks in subject 1, is also getting good marks in subject 2, but the correlation is very weak here. It is 0.12. So this tells the monotone association between the two variables, that is marks x and marks y. We will attach this Excel sheet for your help in notes. Save. So we have calculated Spearman's rank correlation coefficient, that is denoted by RS. In some books you will find this denoted by rho. So now we will test the hypothesis. So first the hypothesis is, null hypothesis is that RS is equal to 0. There is no correlation between two variables, that is no monotonous association. Now alternative hypothesis here would be, that is RS is not equal to 0. So we calculate the value of RS, and if n is less than 30, we will use the t test, in which the relation for t is equal to RS n minus 2 1 minus RS square. So if sample size is large, we can also use the normal approximation, that is normal deviate is equal to RS by variance of RS under root, which is equal to RS into simply n minus 1, that is the normal distribution with 0 mean and standard deviation 1. So this is true if n is greater than 10 at least. So this can be used to test the hypothesis. Next comes a very important aspect in correlation, a very important topic here, correlation and causality. Correlation tells that there is an association between two variables. So it does not tell the cause. So if I take an example, for instance, if I say when it is raining, my friend was saying when it is raining, he has an urge to have samosas with tea. So his consumption of samosas, if I take that data, and rainfall, if you plot the data, that would have a positive correlation. But does that tell that rainfall caused that urge? Or could I say that whenever he eats samosas, there is rainfall? This looks stupid. So correlation does not tell any causality. So what is the independent variable, what is the dependent variable, that is not considered in correlation. So correlation tells that association is there, whether weak, moderate or strong. But if y and x have association, it does not tell the direction, does not tell that x is being influenced by y or y is being influenced by x. This is not given by correlation coefficient. So what do we have? We have a cause. A cause is an explanation of some characteristics, some attribute, some behavior of groups or individuals, other entities, and we have a causal effect. Causal effect is the finding that change in one variable leads to change in another variable, all the other things being equal. The finding controlling the other variables. So, criteria for identifying the causal effect, first thing is, do we have association? So, is there any empirically observed correlation coefficient between the dependent and independent variables? Then do they have time order? Time order is which variable comes first. As I took the example of rainfall and urge to eat samosa, which is a dependent variable, what do you suppose? Dependent variable here would be urge to eat the spicy food. So, rainfall is my independent variable. So, please keep in mind the independent variable comes first. Then non-spuriousness, that there is no third variable, or if there are third variable or the hidden variable, we call that the lurking variables, those should be controlled. If there, those should be controlled. Actually, these three are the required criteria. Now, next I also have the mechanism and the context. Context is the scientific explanation, or if we have some theory behind the correlation coefficient which we are getting. For instance, the example which I have been taking, the time spent on study and the marks and the grades, these are positively correlated. So, there is a theory behind that, that more the student read, more he would grasp the knowledge and more well he would be able to perform in the exams. So, there is a context, there is a scientific explanation. In scientific research, we have the scientific explanation. For instance, in manufacturing, we have some physics behind each process. If there is change in reference, which change in cutting speed of the tool, if tool is cutting the workpiece, there is a change in roughness with the change in cutting speed, there might be some physics behind that. That context can support our correlation coefficient, whatever we are getting. So, these are the criteria to identify the causal effect. So, there are two kinds of relationship. One is common response and second is confounding. The common response is possibility that a change in the hidden variable is causing change in both x and y, that is z is causing change in both independent and dependent variables. Confounding is possibility that either the change in the explanatory variable, that is the independent variable, is causing changes in the responsible variable, or might be that the hidden variable is causing change in the response variable. In this case, my z is the hidden variable. So, actually in common response case, there is a correlation between x and y, and z is affecting both of them. But in this case, confounding, my x is affecting y, also there might be some variable z that is affecting y, that is the dependent variable. So, the dashed line or dashed double line arrows shows an association, that there is an association between two variables. The solid arrows show a cause and effect link. The variable x is my explanatory or independent variable, and this is my dependent variable. So, this causation, there could be certain examples for this. For instance, in winter, the sale of the warm clothes is high. I took the example before. So that is the independent variable is the temperature, the chilling cold, and dependent variable there is y is my sale of the winter warm clothes here. So also I can take the example vice versa here, the temperature rise would increase the electricity consumption. In summer the electricity consumption is high because of the use of air conditions, fans and some other cooling equipments. So this can be an example here for common response. So for confounding I can say there is another variable z that is let me say purchasing power, that is affecting y, the sales, but it is not affecting x here. So there is a causal relationship. Another example I can take the weight of the car, weight of car versus mileage. Simple causal effect would be higher the weight, lower would be the mileage. The more weight would be there, more energy would be used to pull the car. Okay, so that is a simple causal relationship. The common response here would be that the type of the car, the z variable here would be the type of the car. It can be a van, it can be a SUV, it can be a luxury car, it can be a sports car. The type of the car influences the weight plus other factors that affect the gas mileage of the car. Okay. Now the confounding factor here would be the z here could be actually the while the weight has a causal effect, it actually effect cannot be accurately ascertained since the weight is confounded with a number of factors here. These number of factors can be the type of engine, the horsepower and so on. So next is conducting experiments. It is the most powerful way to deal with causality here. When we conduct the experiments, we see the dependent variable and independent variable, we conduct the experiments and control the other lurking variables here, the hidden variables or other affecting variables. We conduct experiments between them and this gives us result that one variable causes the changes in another variable or not. So conducting experiment is a strong or powerful tool to deal with causality. So to conduct the experiments, first thing is we divide our groups into two parts. One is experimental group and the control group. We have the treatments here, that is the experimental manipulation or all these sets here, and we do not have any treatment in the control group. So we should make it sure that there is a random assignment of the experiments here. So while we do the experiments, it is very important to validate what we do. We actually divide our data into two parts. If we have suppose 100 observations, we first do the experiments, we just first analyze the 90 observations or 80 observations, keep the 20 observations for validation. So validation of what we do is very important. So with this I would like to conclude my lecture on correlation. We did the Spearman's rank correlation, we did the demonstration on the Excel sheet here, then we saw the correlation and causality, and for now thank you.